me? Is it working? Oh yeah, there it is. Cool. Hopefully everyone's caffeinated and raring to go. We're going to start doing some jumping jacks. No, I'm joking. So yeah, my name is Salman. I'm part of Weights and Biases. I work as a success machine learning engineer. Today's session will be talking about LLMOps, but really the wider conversation around how can we streamline the path of bringing Gen AI applications from prototyping into production. I'm sure most of you today will have been experimenting, maybe working with a few different things, a few different concepts. You know, we've all heard about RAG, potentially different fine-tuning techniques, maybe even fine-tuning as a service offerings. So ultimately, the question is, there's so many different trends emerging. I'm sure, you know, this line will be used, but next week, in a couple of weeks, there might be something different. So where should we place our focus? And that's ultimately what we'll be discussing today. And part of the session will include things around, you know, the why behind all of this, the key problems that what we're seeing in the industry organizations are facing when they're developing Gen AI applications, the what behind it, so how we're considering the approaches, and again, how we're conversating with customers around how or what the LLMOps framework could look like, and then we'll look into the how behind it. So what do those approaches actually look like? And I'm not a gambling man, but I'm going to do a live demonstration and show some parts of the product from Weights and Biases. So we'll also see, you know, how we're actually doing this using our capabilities. So starting with the why behind all of this, you know, why do we need LLMOps? And I think the conversation should be elevated a bit more into why are Gen AI applications not in production? And if there was a slogan for Gen AI, it would probably be this: easy to demo, hard to productionize. I think everyone will probably be able to resonate with this. Anyone can go on ChatGPT today, throw some prompts at it, you'll get, you know, some nice responses. You can show it to someone, show it to a family member, to you know, a manager or someone, and you know, it looks good. But then you want to bring it into production, and that's a whole different conversation. And it's largely due to things like this, right? It's not just about the LLM, it's about everything else that encompasses how you bring that into production. Google released a paper a while back around machine learning and how they kind of talked about machine learning being the high interest credit card for technical debt. So for those in the technology industry, you'll probably be aware of technical debt being, you know, certain corners that you might cut, certain decisions that you take, and ultimately you have to own that and pay off the debt that comes with those decisions that you make at some point. So what you see when it comes to things like building these LLM applications is it's not just the LLM, it's everything that surrounds it, from other sets of tools and technologies around vector stores and vector databases, your data pipelines, all the way to things like guardrails, error handling, you know, should we fine tune or not? And so that's inherently where a lot of these challenges are coming from, because it's not just the LLM. If we were to boil it down into two areas that we're observing and we're hearing the sort of technical reasons why these applications are not deployed, it will kind of fall into one of two buckets where we're seeing. One being the evaluation side of things. It's becoming very challenging to define what metrics should we use to evaluate our Gen AI application, and at what scale should we start to evaluate. And the second being optimization. So like, you know, we'll hear more and more today, there's so many changes coming, not just to do with models, but again, the previous slide, all of these different tool stacks, all of these different techniques we have to keep top of mind. So then there's an optimization problem. How do we ensure that we can iterate with different components? How can we ensure that we're agile to be able to hot swap when we need to, or potentially pivot where we need to? So that leads us to the what. This is inherently the, I won't say the solution, but you know, the right frameworks, the right mindsets, and the right behaviors to put in place. And I think when we look at things like LLMOps, this is not the first something ops methodology or framework that has come to market. We look at things like DevOps, MLOps, DevSecOps, ITOps. There's so many of these, and inherently it's all about just having something in place that culturally, you can agree on how do we put a set of activities that make sense, ensuring all stakeholders are represented, and there's a culture in place where, as an organization, we can agree on how we move things through different cycles or through different functions. So that's inherently what we're really talking about here when it comes to the what of LLMOps. The specific activities you'd probably see within an LLMOps lifecycle ranges from potentially pre-training and fine-tuning models, but looking to things like prompt engineering, system engineering, working through data pipelines, evaluations, validating outputs with domain experts. And then when we look at the key stakeholders involved, you'll see that, again, there's different teams involved who care about different things. You have your more ML-focused personas who may want to, again, focus more on the pre-training, fine-tuning aspect, who care more about the actual architectural inputs of a model. And then you have the kind of software engineer, prompt expert type persona who's really looking at using that model to build some kind of application around it. So these are the folks that are more concerned around building that retrieval process, looking at using a vector database to build that application. You have your domain experts who want to potentially annotate data sets with their own expert knowledge, as well as be able to evaluate outputs from your GenAI application. And then you have the more senior stakeholders who want to potentially approve models going into production or approve applications going into production, people that sit higher up that set the strategy for what GenAI looks like for your company or how you go about it and aligning it with certain business goals. And then finally, the users of the applications themselves. So all sorts of different personas involved. And the third layer, which is really hard to visualize or kind of describe in a way, is more the cultural aspect of this, right? There's no point in saying this is what we're doing and these are the people involved. The whole cultural aspect, which is a core part, again, of these XOps methodologies. It's always about having a cultural belief within the organization that this is how we go about things, because without that, then you just go back to siloed environments, siloed teams, people working differently. So looking at, a bit of a simplistic view, but a view nonetheless of what would an LLMOps workflow look like. And there's probably three key steps that we're seeing. One, the sort of optimization layer, where we're looking at, again, potentially pre-training or fine-tuning a model, but also the system engineering side of things. So looking at building RAG-type architectures, agentic RAG-type architectures, maybe even the prompt engineering side of things, then moving into an evaluation phase where you potentially have some form of ground truth data set that you want to use to evaluate the outputs of your model, potentially using LLMs as a judge, which we kind of heard earlier in some sessions today, benchmarking different models that you want to use to compare and help give you more confidence around what model are you going to use as part of your GenAI application, and then further down the deploy and monitoring phase where you have an application in production, you want to be able to monitor it, debug it, understand what are the inputs and the outputs to everything that's going on and build these end-to-end traces, while also incorporating user feedback, whether it's quantitative, qualitative, whether it's your thumbs up, your thumbs downs, something to be able to understand user feedback as well. And you'll see on the bottom, the types of those personas that we saw in the previous slide, where they will kind of slot in this type of workflow, and again, what types of things they would care about. On the top, you'll see some of the capabilities that Weights Advisors has, which we'll kind of see later down. But the thing to stress is that we're working with organizations throughout this whole cycle as well. So a lot of what we'll be talking about encapsulates the things we're hearing and the things we're seeing. If we zoom into the optimization side of things, and I think this probably resonates now because there was a question earlier on around, should we fine tune, should we not? And I think this gives a sense of how a typical mindset or thought process works with this, right? You potentially have your foundation model, which we can think of, your GPT-4 in this case from OpenAI, something that has been pre-trained, and this is more general purpose. It should be able to serve, almost everything and anything, but then you want to go through a process of making it more tailored to your own business data, to something that is more specific to a task that you want to optimize for. And I think this is where we get into the conversation of should we fine tune or should we do something else? And I think this is where we get into the conversation of what is fine tuning actually for. And sometimes the purpose of what people want to use this for, it gets a bit mixed up around, do you actually need to go down a RAG type system engineering type approach or fine tuning? Often organizations that are fine tuning will fine tune a model when they want it to, when you want the LLM to be enhanced on an existing task, i.e. you want it to, for the same task that it was trained on, do it that much better, or you want to train it to perform other tasks to perform. So something really, really specific. Like in our case, maybe we want to fine-tune the GPT-4 model to be able to perform some very specific tasks and answer specific questions about some kind of biological team that we want to serve it to. They might have some very specific tasks that inherently needs the model to be updated and changed on. But then we move into step 3, which is really looking at prompt engineering and RAG, which is more around, is your goal to just have the model understand your business and your data a bit better? Because then it's really looking at feeding the model more about you, feeding the model more context in order for it to answer a question in a more appropriate way, or to be able to have more context about your business or your data. So this is where you will take either your fine-tuned model, but you could also potentially just take your pre-trained model and build an application around that, whether it's a RAG chatbot, whether it's some sort of agentic application that you're creating. But ultimately, this is where you will also be able to fine-tune the model in a way, but this is more focused on through means of prompt engineering, where you enhance the prompts that you're sending to the model through things like RAG to be able to feed it data from your own internal knowledge base to give it further context around your business or your use case. And then if we look at some of the specific needs from those different teams that, or these different areas that teams will be working on, from a pre-training perspective, this is where you have extremely long training runs, and then potentially there's needs around, we want to be able to pause at some point, potentially we want to fork the run and then be able to take it through different points in time, be able to asynchronously evaluate the training process at different points. From a fine-tuning perspective, some of these might relate with the pre-training perspective, but this is where we want, people will be more considering things like how will it integrate with other fine-tuning type frameworks that we want to use, fine-tuning as a service offerings that are coming out, as well as being able to understand more about how are we actually using our infrastructure when we're fine-tuning these models. And then from a system engineering perspective, what we're seeing is more around how can we build an evaluation data set that incorporates some form of ground truth, being able to have an end-to-end understanding of inputs and outputs to my application, and having more efficient feedback loops so that users and stakeholders can provide some form of feedback for this application. And then again, from a platform perspective, we'll have a slide that kind of encapsulates what models and weave look like. But again, from a weights and biases perspective, we're working with teams who want to train and fine-tune and productionalize those models, but we're also working with the teams who just want to use those models and be able to build those applications around that. So moving into the how, this is where we'll take a look at a case study internally that we worked on building a documentation chatbot. It is available for external users as well. But to kind of give a sense of where we're coming at it from the how perspective, how are we working with organizations to actually build a robust framework to get these applications from POC to production. And our core belief is really around being able to experiment, and that being a very reliable source of information. It will be very difficult for me on the stage to say use X, Y, and Z, because then in a month's time that can quite frankly become very irrelevant, or it just depends use case to use case. So your intellectual property, your key learnings really just come from being able to experiment and iterate very quickly so that you're able to hone in on the things that are specific to your use case or to your business. So this is where we're working with teams on, like I said, training and fine-tuning and productionalizing models. So where you're focused on wanting to take something that you're working on yourself, or potentially taking something from a repository like Hugging Face and fine-tuning yourself, we're offering the capabilities and have been doing for a long time with teams to do that. But like I said, we're also working with teams who are developing GenAI applications, who are more just concerned around how am I able to monitor and debug and build an end-to-end trace of what's happening within my application to make this even bigger black box, something that is understood, and then also having more rigorous systematic evaluation techniques so that I can build more confidence to at least recommend and put these applications into production. So I'd like you to meet our esteemed wandbot, our documentation assistant. This is something that one of our machine learning engineering team at Weights and Biases worked on to build a more contextualized document assistant that we use internally, but is also available for external users. So there is a GitHub repository, and we do have a course online that is more focused on building these types of RAG architectures and is focused on this use case. So you're more than welcome to also sign up to that course and work alongside Cohere and Weaviate on how we built this. But I think the reason why I wanted to show this architecture slide is not just to say, this is what you should use, but if you kind of look back at that technical debt slide and all of those different components that encompass this type of application, you'll see that the model is just one small bit within this wide, massive ecosystem. So it's important to understand that there are different considerations to take, and you may well want to start off with Llama Index as your framework today, but maybe tomorrow you want to use LangChain. And the only way you will be able to know what paradigms and what techniques and what tools will fit your use case is to be able to have an environment where you can flexibly work and have the freedom to be flexible with these sorts of tools. Going back to the wandbot use case, this is probably something that most people have experimented with or doing today, and this is sort of the very basic RAG workflow. And you have this simple process of a user submits a query to the application will then search your knowledge base, i.e. your vector store, retrieve some relevant documents to add as context to the query, which then gets passed back to the LLM. The LLM does its magic and then gives you a response to pass back to the user. Our team felt that this was not production ready, and there's a few reasons why, and this is where we move into more of an advanced and somewhat bit of an agentic RAG workflow, and you'll see the highlighted bits that our team added where this is what they considered when building wandbot. So you'll see the concept is still the same. What's happening is still very much similar to the previous slide, but you'll see that there are some extra bits that were added to make this a bit more production ready. You have things like, for example, the query gets sent to the RAG system, but before it searches the internal knowledge base, the query gets enhanced, right? So you would remember from the architecture slide, there was a Cohere bit, which is using to enhance the query. And that's because users might ultimately just be very lazy. I mean, I know myself, I'll go on ChatGPT and write a very lazily written query, but it doesn't encapsulate exactly what will make the most sense or some relevant context that will help retrieve the right documents from your knowledge base. Once the documents are retrieved from the knowledge base, you'll see that there's a re-ranking step straight after, and that helps optimize the process by putting the most relevant documents up top first, and that being fed to the model. So the model gets the most relevant context based on how you want to rank that. Once the LLM generates its output, we then have a validation step, which then ultimately is a QA check, right? Before you actually pass your response back to the user, a sort of final check to say, does this make sense? Does this pass some quality gates that we have set before we pass this back to end users? And this will be really important if you consider something like wandbot. If we're passing it to external users, we don't want to have a RAG chatbot passing out any type of response that doesn't make sense, something that's incorrect about the product, something that may potentially be, maybe not for this use case, but maybe something that's harmful or toxic as well. Being able to have these quick QA checks before you pass that is like a final tick box. And so the things that our team considered and what we tend to, when we're working with customers, often make them realize is, the process of bringing a RAG into production is really on focusing on reliability and scalability, being able to perform these evaluations at scale, being able to use component level metrics, so i.e. being able to understand inputs and outputs, what was the query the user sent, what were the documents that were retrieved by my vector store, what was the output from the model, et cetera, all of these different component level metrics, having use case specific data, so again, being able to take data that is relevant to you, your organization, and be able to use that to compare with outputs from your model and evaluate it, while also incorporating user and expert feedback to have a mix of not just quantitative but qualitative evaluations and have a full picture of, does this make sense or not? And I have a slide later on which kind of talks about some different evaluation strategies and kind of how that can be incorporated. So what I'll do, on the left-hand side, we see some key capabilities that are focused on online monitoring, so your typical production monitoring, tracing, understanding what's happening in your application, and then offline evaluations is a way to be able to systematically benchmark your data, be able to evaluate in a way that makes sense to you, while also having periodic optimization of models, so using those evaluations to, again, understand where are the limitations and how you can fine-tune your model through things like whether it's enhancing your prompts or potentially whether it's something to do with document retrieval, et cetera, et cetera. So what I'll do is I'm going to jump to weights and biases weave. So if you remember, this is part of our product area that's focused on developing these Gen AI applications. I'll do a bit of a zoom. So you can imagine your RAG application or your RAG chatbot will have multiple different functions. So, I can drill down into specific functions in my applications, whether it's evaluation-based functions, whether it's around the embedding functions of the LLM. But what I'm going to do is, and probably what most people will initially want to go to, is the actual predictions from the model itself. So this is where that user submitted the query, and then it goes through the process through the vector store to the LLM and get the output. So what we'll see here are all of these individual traces. So these are calls to that LLM, which are then going to go through that process. And then if I click on one of these, I can easily see the end-to-end trace of that specific call. So the parent in this case was an evaluation call, so being able to predict and then score my output from the model. So here, for example, we'll see that the next step was that we go through this predict function, and then it will search the vector store, which then I can drill down into further. It will format the prompt. It will then send a prediction. And then, for example, I can look at things like, well, what was the actual query that was sent? How many documents were pulled out? What was the actual output of the model itself? I can also drill down into the vector store function and then look at what were the actual specific documents that were pulled out from my vector store. So this all goes back to the understanding of what are the inputs and the outputs for my model. And qualitatively, I can start to eyeball this and look at, does this make sense? And most organizations today are at this eyeballing phase where they just look at the output and see, does this make sense? What I can also do is I can be able to incorporate user and expert feedback as part of this. So what I can also do is say, hey, look, maybe I have in this case, a chatbot use case, and I just want to be able to embed a way for my users to give feedback that I can then visualize back in Weave. So for example, I can, just copy this piece of code, add it to my chatbot, and then give users a way to add a thumbs up or a thumbs down, add a comment, and this will then help me, one, filter down and hone in on, once we have all of these traces, certain areas that I want to dig in on, but also help build a annotated evaluation data set that I can use further down the line. We can then jump into looking at evaluations, and then this is where we want to look at benchmarking my model. This is where I want to look at how can I put in metrics that I can use to quantitatively also evaluate my model and look at understanding, again, where are its limitations, as well as other parts of my RAG application. We also have some other metrics that look at document retrieval, and also hallucination and safety metrics, whether it's to do with the prompt itself. So what I can do, for example, is I could say, let's take my GPT-4 model, and then I want to compare it with this Claude 3 Haiku model. If I click compare, then we get some nice, beautiful visualizations. But the whole point of this is to make it easy for users to compare these models. And like I said, one of the key challenges around the evaluation was being able to do this at scale. So potentially you may be comparing multiple different LLMs, potentially from the different providers, or maybe ones that you fine-tuned yourself. So this gives you a very easy way to, at a high level, at a glance, look at where do certain things compare based on the metrics that you are judging the models on. We can then zoom into more quantitative metrics. So maybe I want to look at how do these models compare when I look at my correctness metric, when I look at my hallucination metrics, and I can easily start to understand maybe in this scenario the Claude 3 Haiku model performs better on these metrics than the GPT-4 model. But what we can also do is qualitatively look at the outputs and evaluate it through that way. So I can look at different examples that I sent as part of my evaluation data set, and then look at what was the query, what was, in this case, the ground truth, and then what were the outputs from the models respectively themselves. So I have 7 different examples here, but what I can also do is go up and start to look at plotting different metrics against each other, and in this case, we have the correctness metric, and I might be curious to know, because we saw the Claude 3 Haiku model outperformed or quantitatively outperformed in some scenarios, so let's zoom in on scenarios where the Claude 3 is more correct, where the GPT model is not correct, and you'll see that this dynamically, will dynamically adjust the qualitative output. So I can look at the 2 specific examples where I know that the Claude 3 model outperformed, the Claude Haiku model outperformed the ChatGPT model. And then I can start to qualitatively analyze this as well. And then this is where we can start incorporating experts, domain experts, to be able to validate this as well, and also incorporate that cultural aspect when we were talking about these sort of ops type methodologies, to have these users embedded as much as possible and integrated as much as possible in these workflows. Through this, we can also create these quality gates that we were talking about earlier. So potentially we might add pass-fail type scenarios where X's fail, tickers pass, and then we'll also use this as a means to filter down on certain scenarios. So maybe I could go back to the evaluation scenarios, and I might be able to want to hone in on things like, well, what exactly is the limitation here? Is the limitation the model? Is the model incorrect? Is the limitation maybe document retrieval? Or is the limitation to do with hallucination from the outputs themselves? So what we can do is then dynamically filter. Maybe I want to look at where are the scenarios where both the Claude 3 Haiku model and the GPT-4 model are getting things incorrect. I'll skip through these just thinking, yeah. So I mentioned earlier, I have a slide about evaluation strategies, and what we're seeing at the moment is most organizations are at this eyeballing phase where they just look at the outputs and, does this make sense? This does not make sense. I had a colleague the other day who tried to build a Spanish translation chatbot, and he was just eyeballing it, and then he quickly realized, I can't really tell if this is accurate or not because I don't know Spanish. So, you quickly start to see where the limitations come from eyeballing, but you know that it's not reliable, but it's very quick. But then you can move into the more reliable methods that are more, manually evaluating it, and getting domain experts involved to actually look at each single generation and each single output. But although that's the most reliable, it's the lengthiest process. And then you have a bit in the middle where we see organizations using LLMs to evaluate other LLMs. And then this can also become its own rabbit hole, because then do you want the LLM to evaluate the evaluator LLM, which is evaluating the other LLM? But this ultimately gives you different strategies where we're seeing you start to balance reliability and speed. But where we're seeing the best success is where you're able to integrate and merge these different techniques together. So I know I have about 30 seconds left. So to end things, this kind of encapsulates most of what we talked about. We saw the challenges that organizations are facing around being able to systematically evaluate, give confidence to put applications in production while being able to iterate very quickly. So a sort of blueprint that you can think of that will at least give you the foundations to be successful is being able to monitor production work qualitatively, but also being able to gather feedback from experts and users, as they are the ones that know the use case and the domain as best as possible. Having systematic evaluation pipelines to give you quantitative measures that you can correlate with the qualitative measures, and then finally being able to iterate and do the cycle all over again when needed. So thank you very much for your time. I don't know if we have time for questions, but happy to also come back to the booth. Thank you. We've also got some quick starts and guides if you want to capture the QR codes.
Thank you. It was a nice presentation. Do we have questions? Thank you.
Thank you. So I have asked so many questions, sorry for that. But I do have a question related to the enhancers. You show a very nice like flow to change the current RAG and the theoretical RAG to the actual implementation of the RAG, and the enhancer that you include and the re-ranker that you include. What techniques do you suggest to enhance the question to improve the results of the semantic search? Because we have faced issues with that. So when the user asks a question, we try to get the most relevant documents, and the most relevant documents are not the proper ones because we need to enhance the question. But what are the techniques that you can suggest to enhance the question? And the re-ranker one, I would like to have like a more explanation of what you mean by the re-ranker.
Sure. To answer the first question around the enhancing step, what we typically find is that this can vary use case to use case, because then it's around how do you enhance the prompts that users are sending. Often it will likely be a case of trial and error, because you want to look at what are the types of prompts users are sending, and potentially looking at, are there any trends that you're seeing in terms of any behaviors that are impacting the quality of that prompt. So looking at the prompts that users are sending, and that's typically where we see like the traces help, because then you can look at what queries are my users sending, and are there ways that I could improve on that. So really it just comes down to prompt engineering techniques, really. So looking at the queries themselves, and is there a way to improve that and incorporate, if there's a way that you can automate part of that, like if there's a general issue that you're seeing with the prompts, i.e. they're not specific enough, then we saw with the DSPy session, for example, like there might be ways you can use these types of frameworks to at least automate it in general, right? But there might be other edge cases where you still need users to have that kind of knowledge. The re-ranking step, some of it is documented on the GitHub repository, but yeah, happy to dig deeper on it if you come by the booth, yeah.
Well, thank you so much for lots of insights. I am interested in digging a bit deeper into this interaction between the domain or prompt expert and the machine learning person here. So we've heard different aspects, right? Alberto talked about prompt engineering as done by the system itself. Nico mentioned, hey, you really want to have the system, the domain experts as part of the prompt engineering, as part of the evaluation. Yeah. You have made this distinction between the prompt or domain expert and the machine learning person. So from your experience, and I'm sure you've worked with plenty of teams, what are, from an organizational perspective, a good setup to combine the prompt engineering / domain expertise and the ML engineering? What are things that you've seen working well? What are things that you've seen really set up for disasters? Or let's say set up for failing at least.
I think in practice, mostly what we're still seeing is that ML teams are still taking on most of this responsibility. So because it still inherently comes down to model behavior and understanding the model themselves, that's why ML teams are still more focused on this. So there isn't necessarily like a prompt engineer within the business. So the domain experts, really it just looks like with most other setups with MLOps, DevOps, etc., just having the collaboration and communication with those teams to understand what does good look like, what does this actual domain look like, and where we saw with the qualitative outputs, having an expert actually look at the generations and the outputs and be able to look at something like that and say, you know, this actually does make sense. The content that it used potentially from our internal knowledge base does make sense. So it really is more from like a collaborative setup. But then in other organizations, you might have the concept of a prompt engineer or domain experts wanting to be more involved within the development of this. So I wouldn't say there's a, strictly speaking, like a one-size-fits-all, but I'd say that the important aspect behind all of this is collaboration, to be able to have something that allows you to integrate different teams, right? Like we saw earlier, you have activities and stakeholders, but it's really the culture that glues everything together. So having everyone on the same page and having the means to collaborate is probably the most important thing that sets you up for success.
And are there any recommendations that you have about how to make this work? As in like, hey, have that one meeting beforehand where people really talk about this domain, or any tips, tricks?
Kind of varies use case to use case, but again, like when it comes to scoping and requirements gathering, that's going to be the most important phase, right? You might have an idea of a GenAI use case or an application, maybe it's driven top down. The most important thing to do is in those initial requirements gathering phases to involve the domain experts early on. Helps you validate feasibility, again, helps you understand the domain more clearly, and allows them to be as involved as early as possible to understand, you know, what exactly you're trying to do from a technical perspective. And then as you're iterating through different cycles, having them also part of the evaluations, right? Being able to give their opinions and feedback. So I'd say definitely early on when gathering requirements is very key, and then as you continuously iterate and evaluate, having them be part of that evaluation strategy.
Great presentation, and great to see the tooling starting to come together in a really nice way to be able to step through your pipelines bit by bit. Two quick things. One on quality, just to respond, and I'm happy to talk to you at a break maybe, but it turns out in both the academic research as well as in practice, the R part of RAG is so important to the quality of the output of the generation. So that retrieval element, not just relying necessarily on vector alone, but being able to do hybrid and other elements that we've used for years in information retrieval are so critical. So do those show up? So the questions I have for you are, is there a way to expose that through Weave so we can see sort of what that, you showed a quick example of the documents that come back, but how do we think about scoring those documents or controlling the documents that come back from that vector database? And then the second question is, and I apologize if I missed this, do you have an evaluation for looking at different embedding models as part of that vector ingest process as part of your Weave dashboard?
Yeah, so to answer the first question, absolutely, like that is, like you said, a very key part of the 3 components of RAG. There was a brief example of like a metric where we were using to understand first document retrieval. So there are metrics that you can put in, and ultimately that comes as part of the evaluations part of the Weave platform, in that you can define these different scoring functions as you best see fit. So we don't necessarily come at it from an angle of saying you should only use these, because then again it varies use case to use case, and different organizations will evaluate in a way that makes sense to them. But absolutely, you can embed those metrics and then use that as a way to understand the retrieval step. You can also, we didn't see an example, but actually look at the code that was used to execute it. So you can actually look at what's really executing in the application. And to answer the second question, yeah, absolutely, you can add evaluation metrics for embedding models too.
So it's extendable?
Yeah.
Thank you.
I just wanted to continue the previous speaker's question. So obviously you have some metrics to validate a particular model. So what would you think about using RAG and LangChain and getting the most optimal? So essentially making RAG search algorithm, right? Getting the best prompt or the best retrieved document. So what is your thoughts on this?
So could you repeat the question, please?
So using RAG and LangChain
Right.
as the best fit, right? Because you have scoring metrics, right? If you use LangChain, you'll be able to find the best ways, right? Which models can be used, like Claude has to go first or ChatGPT has to go first. And so if you use this as like a search methodology, like to find the best fit. So how would you do that?
The how behind it would probably be a very lengthy conversation, but I think the ultimate thing that we're putting across is, from a mindset perspective, is you kind of have to experiment to figure out, right? I hate to use the "it depends" answer every single time, but because it does vary use case to use case, the concept of being able to experiment and look at, for example, like you said, what's the order of how we do this, or what components do we use? That learning comes through being able to experiment. So again, we do not want to come at it from an angle of being very prescriptive, likely because this is still an industry that's evolving and still being defined, so it's hard to say this is the right way of doing things. But if that's an approach you want to take, you should have the means to be able to experiment and then document and understand. Very similar to what we've seen in the software development industry, right? You saw the traditional waterfall methodology, and that very quickly developed into more agile scenarios because requirements can change very rapidly and approaches can have pros and cons associated with it. So we're kind of coming out from a similar angle of what we saw in the software development industry, where you just want to be able to experiment and iterate quickly. But happy to have a lengthier conversation back at the booth.